Hello, I'm Hannah Seppala, and this is my application for the WPI Design Innovation Scholarship. I've been a member of First Team 1511 Rolling Thunder for the past 4 years. This is my third year as Team Safety Captain, and my second as an elected member of the Leadership Subteam. As Safety Captain, I give weekly presentations to the entire team throughout build season. For all 4 years, I've played a major role in mechanical design of the robot and been a member of pit crew. I've also done a majority of the physics calculations for the robot, this year including calculating the trajectory of the ball and the angle and power of the shooter. This year, we used a different tactic to decide on the robot design. Historically, we've always chosen an overall design and made subsystems that would fit into that design. This year, we did it backwards. We decided on the actions that a robot should be able to perform and created subsystems able to do those. We then assembled those subsystems into the main robot. We had our basic subsystems laid out pretty early. There would be a drive base, a gear manipulator, an intake, a shooter, and a conveyor system of some kind to take the balls from the intake to the shooter. At the beginning of build season, I was placed in charge of the design of a robot subsystem. I originally wanted to work on the intake system for the balls, but as a conveyor system seemed much more difficult, I volunteered to work on it instead. Our first batch of designs were the bucket design and the conveyor design. This came down to an entire team decision. Each subteam, mechanical, programming, electrical, and strategy, got a vote. During an integration meeting, we presented both designs. The mechanical subteam was the only group who voted for the conveyor design, and the bucket design was chosen. A couple days later, we realized that the bucket design was too likely to jam and could not provide balls to the shooter at the rate that we wanted. The second round featured many more designs. This is a spreadsheet from the decision-making process, which shows the capabilities of each design as well as the final vote. The design that won this round is called the drum. The mentors who weren't present for the design decision vetoed this design the next day, due to concerns about motor placement and space management. Our final decision was made a little differently. At this point, we didn't have time to get the entire team involved in a discussion. While we try to have such team-based decisions as often as possible, sometimes we need to work quickly and don't have time to bring everyone up to speed on a wide variety of designs. This time, the head mentor, Larry, grabbed the 2 strategy mentors, the team captain, and me. We went downstairs and had a backroom discussion straight out of Hamilton. I jokingly wrote a piece for the team blog about being in the room where it happened. Larry said that we were going to pick the final design at that point. We bounced around a couple of thoughts and ideas, and then I said that I had an idea. Immediately, the 3 most influential mentors there that night and the team captain were staring raptly at me. After a couple minutes of discussion, we decided on that design. It's a very basic conveyor system. There's one bar right behind the intake with chicken plucker material on it to carry balls into the hopper. The bottom of the hopper is composed of a conveyor belt, which carries balls to the shooter. I did most of the CAD work for that conveyor design. Once that was done, I helped the shooter subteam and ended up doing most of the design and CAD work for that as well. This design is innovative because it takes what we have done previously and builds on it. For example, these brackets holding the conveyor belts up are based on our 2012 robot. I took the same design and added a bearing plate on these brackets to add another degree of adjustability. The design process we used this year is different from the process we've used in previous years, but it was very effective. Our early prototyping allowed us to test a variety of different designs, and our numerous iterations allowed us to pick a final design that incorporated some of the best elements of previous designs. While we did finish behind schedule, we were still able to finish the robot by the end of build season. We pride ourselves in our gracious professionalism, known to non-robotic students as sportsmanship. As a member of pit crew, I help to keep a log of all the tools, parts, and stock we lend or give to other teams. We work hard to make sure that everyone else has everything they need in order to succeed, even if they're going to be playing against us. Working with a group called Enable, our team has 3D printed 44 prosthetic hands for children around the world. We also make an effort to help or start new teams. I've attended the first National Advocacy Conference in Washington, D.C. for the past 2 years, where we meet with our national representatives and advocate for funding for new first teams. While our team is a robotics team, we're also a family. As a member of the leadership subteam, I help to organize a wide variety of events before, during, and after build season. We have a handful of funky team traditions, such as our birthday celebrations.
Happy birthday!
Thank you for this opportunity. I'm excited about the possibility of attending WPI in the fall.